Good morning once again. It's Mr. Pete, your YouTube shop teacher, and this time with a short video on the reconditioning of a Cardinal speed vise. I've talked about this before. I have two of these. This is a 3-inch, this is a 4-inch jaw, and this one really is in mint condition, apparently never used at all. This one is in rough shape, and that's what it's all about, and most of them will look like this after a life in a shop. So I want to try to make a new bed plate for this and get it installed and possibly plug a few of the holes here. Probably not worth messing with, but we'll give that a try, and paint it so it's a semi-restoration. I always hesitate to use the word restoration because I'm not going to surface grind it or do any of that fine finishing that some of you have come to expect. Lately I've been putting some still photos at the end of the video, so be sure and check those out. This is a 3-inch, so it's model 3B and made by the Cardinal company, and it's called a speed vise. And looking at the bottom there, you can see manufactured by Cardinal, patented, Glendale, California, USA. I think they still make these. I'm not totally positive. They are quite expensive. I would think this would be over $200, and so watch for used ones, but it's very hard to find a used one that is not mutilated. As I was examining this vise, I thought, well, somebody removed the replaceable jaws, or they were so mangled that somebody took them out and threw them away because they aren't totally necessary for the vise to be used. But upon looking at my other one, it also has no jaws, but notice that there are holes for jaws. So I finally looked up on the internet, and it appears that the replacement jaws, and there were several different kinds, are an option. This picture came from Keith Rucker's Vintage Machinery site, and there is a picture of it with the spare jaws, and there were several different kinds. Some have these, some do not. Available at extra cost. This picture originally taken from the 74 Popular Mechanics, and in that book, that vise was $29.50 at that time. It's probably 10 times that now. And why is this vise called a speed vise? Because you can very quickly move the jaw in place. There's a thin piece of work. Bring the jaws up, tighten it. There's a wide piece, so you can move the jaw in and out real quickly. That same principle was used on some other vices. Let me show you another one that I have. I got to go out in the garage, and that is on that little Craftsman horizontal bandsaw. So several companies used that device, or that method. Put in the comments if you know of other uses for this Buttress thread. Here's this little Craftsman commercial horizontal cutoff saw. It's a rusting hulk awaiting my attention, which it may never get. And they have an awful lot of nerve to call this commercial. But anyway, it also has a vise made with a buttress thread for rapid movement. And possibly this is a better view of it. Of course, here's the thread for the vise, the movable jaw, and there's the half nut. Very rusty, of course. Enough on that. This is a buttress thread. Perhaps you never heard of one. You won't see them very often. They're mainly used on this type of application. They're sometimes called a sawtooth thread or a one-way thread. They are flat or virtually flat on one side, and now when I lift the thread out of the half nut, you probably can see better the form of the thread right here than what you can on the screw itself, and there might be some wear on the screw. But they allow rapid action. I think they're also used in some hydraulic fittings. Now you can look this up in Machinery Handbook. You're not going to find a whole lot about it. and I did determine that not all of them use the same angle. Some are 30 degrees, some are 45 degree. I don't really know which this is, and I don't really care because that's not the purpose of this video. Also note that there's a slight bend in this screw. I do not intend to try to straighten it or replace it. Sometimes called a one-way thread because they have great pressure in this direction, but when moved in the other direction, and I put a stop here, you watch the thread jump out of the nut. You see, they're one way only. This next picture is out of the wonderful engineer's black book. Notice here that they call it a sawtooth thread, and that's a 30 degrees. Not all of them are 30. And uses, mechanical industry for motion transmission screws, one direction only. That gives you an idea of some of the math involved, but in studying these, that math really varies depending on the application, I suppose. That's all I'm going to say about that thread. I want to move on to what this video is really all about. I've never had one of these apart, but it looks like there's only 2 bolts, and I've already loosened them, so let's take out this 15/16. And that's a fine thread. Soft bolt, and this one is a hardened bolt in both vices. That's hard, that's soft. And that piece is in virtual perfect condition. And now looking at this piece, flipping it over, you can see that the nut fell right off and that the movable jaw will slide out. Now that had to be a hardened bolt there, and you can see why, because there'd be a lot of shear against that. Whereas this one is firmly captured there and cannot move. The bolt only more or less holds it in place. Let me knock that loose with a lead hammer. I wonder if this is reversible. Okay, let's see if that fixed jaw comes off the bed plate. And it does. Easy enough. Now I'm going to clean this up a bit and just see if it is reversible. But I see that there's at least one drill hole that went all the way through and a little bit of damage here on the edge. Other than that, this side is in good shape. Yesterday, in getting ready for this video, I spent over a half hour, probably 45 minutes, in trying to locate a piece of stock for that bed plate, and in fact I did. There's a piece of 3/8, is what I needed, but of course it's bigger. That's been laser cut, so this would all have to be machined down to the exact size here, but I think I have a change of heart here, and I wasted my time on that because it looks like this is reversible. And the only problem with this is that Bubba had drilled a hole all the way through, and I'm surprised it didn't enter the casting, but at that point he must have given up. So I'm going to plug that hole. Not a whole lot I can do about what you see on the side here. I suppose it could be filled with weld, but I don't think it's worth it, considering it's an old vise with a bent screw. So the holes line up, and that's what I'm going to do. I hope you don't think I'm taking the easy way out, although I am. According to this drawing, it calls this part the screw and handle assembly with a snap ring. So it's held in with a snap ring. Notice there's no other access to it. And I am able to see the snap ring, and it looks like it's a one-way deal. That is, they assembled it at the factory, and that's it. I have no idea how to get it out of there. I did look in with a little flashlight. and I don't think there's any way to get in there. Yeah, they really painted themselves into the corner, or painted me into the corner. Can you see the end of that retaining ring there? I just don't see how you would get it out, even with a little pick. I'm going to leave well enough alone. Alright, I changed my mind. You shamed me into it. I am going to tackle this, because this would be so easy to fix, but that is still quite unsightly on the side. Although all of Bubba's sins here would be face down. So all I have to do really, since this is the right thickness, is to mill one side down, cut it to length, and then saw and mill the other side down to what amounts to here 2.5 inches. The plate is set up on the milling machine. It's still too long, but let me start by squaring up, truing up, and removing the flame cut marks off of this edge. Just about 10 thousandths is all I need. Now the workpiece is repositioned in the vise, and I'm going to square up the end, and I'm using this 3/4 inch solid carbide Niagara cutter. I just love that, it's so sharp. Alrighty, this is my square corner. This end and this edge have been machined off and are true. This piece is exactly 9.5 inches long, although that's probably not all that critical. So I will saw this piece off on this line that I'm laying out, and I'll probably put some dye on there so I can see it better. I'm using my new Craftsman bandsaw, 15 inch. Wow, does that cut nice and straight with that Starrett bimetal $60 blade. Alright, the material is cut and machined to length. I milled that off. Probably no possible need for that, because the original is either just abrasive marks or saw marks. It is not that critical. But I don't know, sometimes I waste time. Totally wasting time, because all I needed to do was this. Alright, 2.5 inches. I will saw that off camera. It's a rather long, tedious cut through 3/8 stock, even with that nice bandsaw that I just fixed up. Be sure and watch those videos, by the way. That's waste stock. I'll stay a little bit away from the line, and then I will mill it to 2.5 inches, which really needs to be pretty close, within 1/1000th or two, so that it will fit into this jaw, and the sliding jaw will not wobble. Alrighty, it's cut down close to the line, ready to mill, and with this piece of the waste stock here, this is too small, but it kind of reminded me of what I might do later on, depending on how lazy I get. But this can either be milled clean, but it'd be a very difficult piece to hold, but I might make jaw plates out of it, and that 3/8 stock would be just about right. So we'll see later on. That way it would save the machining of those pieces. And it probably could be thinner than this material, but let me take this over to the mill now and take it down to exactly that size. Now, if you're one of those trolls that is just wants to talk about crickets squeaking in the background, I'm going to have to ban you, because it is very discouraging to spend weeks and dozens of hours on a project, and then the only comment I get from the trolls is, "Why don't you kill that cricket?" Sorry to rant. Before I go over to the Bridgeport mill and mill the new piece to exactly 2.5 thousandths, remember this is the old one, it might be interesting for you to know that the fixed jaw here has a dimension of exactly 2.5 inches for the slot, but the movable jaw, and of course we want that to be a sliding fit with just a little bit of play or it would be troublesome, but that slot is 2.512, so it's 12 thousandths over. Let's go. I'm back at the Bridgeport mill, and this is the new piece, and I'm milling the second side, and this is the last pass, which will take it down to exactly 2.5 inches. So let's get started on that. There's just a few thousandths to be taken off, and I always like to approach a final dimension very slowly because you can very quickly ruin the work. You can't put the metal back on, unless of course you're A-bomb. Okay, I took the final pass and I am right on. I've already mic'd it there. Both ends are the same, or within really 0.2 of a thousandths end to end. And the fixed jaw goes on with a struggle, but remember it came off with a struggle. And it's tighter than a bull's hind end in blowfly season, but that's what I want. And then of course the movable jaw will move freely. Alright, now I can take it out. Never take your work out till you're sure of your final dimension, and always check for fits if you're able to. Okay, I'm very happy with that fit. And I actually had to tap it a little bit with a lead hammer to get it seated, and plenty of play right there. Now the next thing I need to do, of course, is to drill these two holes. 1, 2. That's around half. That's about 5/8. I'll have to measure them. So you can see this is about the same fit that I had when I removed the fixed jaw from the old plate. Remember, I had to use the lead hammer, so I got the same fit now. I have decided to transfer the holes off of the old plate rather than off of the body itself. And that's kind of an odd dimension. I know it would be on the center line of the piece, but I think I'm going to go ahead and transfer it. But in my set of transfer punches, they only go up to 1/2 inch, so I have the correct one for this end. But of all the things in this King Edward's Imperial box, remember when I bought that last year? And these are homemade transfer punches, all kinds of odd sizes, but seem to be pretty well made. And I found one in there that's the exact size. Matter of fact, it's quite a tight fit, but so to give me an accurate location. Alright, let's have a fit up and see what happens if the holes actually line up. Alright, the bolts are just finger tight, but everything fits up just nice. So I'm going to take it back apart And of course I have to get ready for a paint job as well. I'm going to try to match this color approximately, but that's always hard to do. But the next thing I believe that I will do is to plug some of these holes here, and I do plan on making jaw plates. But it's coming along nicely. Okay, here's the game plan, because I'm not going to show most of this. As you can see, the jaws look just horrible on the inside, but I'm not going to do anything to that other than to dress them, because that will all be covered with the jaw plates. But looking at the top on both pieces, the deeper holes I'm going to attempt to drill out and then drive just a soft pin of steel. These are cast iron, so it may look like a different color. I don't think I'm going to do all of them because it would be too tedious, and I'm certainly not going to fill it with brass, which somebody's going to suggest. I know they are, but then it's another color. To me that would look worse than what it looks like now. And I am not this is cast iron. I do not weld cast iron, and I'm not going to send it to somebody else. There will be a dressing cut taking over on the milling machine when I'm done, to get some of the hammer marks, because this thing is old and been beat up, but typical, really typical. So I'll get back to you in a little bit. Not too much I can do about these holes where we have half a hole. That would have to be welded. But it's going to look better than what it is now, but never totally brand new.